G'day viewers. If you understand how a capacitor works on DC, I'll show you an easy way to understand how a capacitor reacts in AC. What happens with the capacitor reactance, whether it goes up or down. When we say reactance, think of the word reaction. So we're looking for what reaction does a capacitor have to the circuit. So we start off with DC, and if you saw the video that I made earlier about capacitors, we'll look at the toilet cistern. So as the toilet cistern charges up, just like a capacitor when it charges with an electric charge from the voltage, and then of course it reaches nearly the top and it chokes off, it stops. So it actually stops the flow of water. Same with the capacitor, it stops the flow of current. So what reaction does a capacitor have on a DC circuit? It stops it. Can't get much more of a reaction than that. If you remember my little diagram of a capacitor that looked like this, our toilet system, we've got our current flow that comes through as soon as you start charging the toilet system or start charging the capacitor. But what would happen if before the water level got to our float here, which is at 63.2%, what if before it got to that level, we then press the button? Is it going to stop the current flow? If we were to, if you can imagine, if we just keep pressing that faster and faster, if we get to 50 times a second that we're pressing that button, we're still going to have current flow. We're not going to be stopping the circuit. So as we get a faster frequency, then we get less reaction to the system. I like to say that we should take everything back to the basics, take everything back to the ridiculous, if you like. And let's say we've got a center line here. So that is our oscilloscope. And what I'm going to do, I'm going to draw a very slow AC current. Okay, I'll start over here. Okay, so now I'll draw a AC current that's very slow. I'll be there shortly. Okay, here we go. And now here we are here. And we will, and then it's going to taper off onto the negative over there. So here we've got a very wonky but a very slow AC circuit. I'm pretty comfortable to say that we can make that a little bit neater, and let's say that we've got DC. So a very, very slow AC current could resemble DC. So if you can imagine that with our toilet, if we were to start filling the tank, but it's going to be 10 minutes until we press the button on it, which would be the same as, let's say it's 10 minutes if we actually change polarity of our electrical circuit, then as you can imagine, the capacitor is going to charge pretty quickly and then turn the power off. So on a slow frequency, it's going to have a huge reaction to the circuit. But we speed it up by pressing that button, it's not going to have much reaction at all. So the reactance in our circuit reduces if we speed up the frequency. Okay, hope that helps. See you tomorrow.